Right, so we did chapter 1 yesterday, just the first section. We're skipping the rest of chapter 1, now we're jumping to chapter 2. Okay, so chapter 2 covers a little bit of stuff on angles. We'll talk about how we measure an angle, different units we use. Okay, and we'll come back to chapter 2 throughout the whole year. Okay, but for this week, we'll do section 2.1. Just that one section, all week. Okay, so before we can talk about what an angle is, we have to define the parts that make up an angle. Okay, one important term to understand when you're talking about an angle is a ray. Okay, so a ray, it's like a portion of a line. It extends in one direction. It has a starting point. And that starting point is called the vertex. Okay, and I said that, ray extends in one direction forever. So when we take two rays, okay, and you put them together, and each of the rays has the same vertex. Each ray starts at the same point. That's when you get an angle. And there's an example. Okay, two rays. There's one. There's two. Put them together so they have the same starting point. Now you're just creating an angle. Can anybody be a little bit more specific about what kind of angle that is if we were to measure inside there? Yeah, it's an obtuse angle. It's bigger than 90, but it's smaller than 180. Okay, so that's our definition for an angle. Okay, when we draw an angle, it has two what we call sides. Those are the two rays. One side is the initial side, the other side is the terminal side. Okay, in the initial and terminal side, the way you figure out which one is which has to do with how you're measuring the angle. Okay, if you're measuring it in a clockwise direction or a counterclockwise direction. I want to be a little bit more specific on this one. I measured it in that direction. That's counterclockwise. So the initial side is the side you started from. The terminal side is the side you ended at. So here's another example. Initial side is the horizontal. This time the terminal side is the one at the angle. Okay, and what kind of angle is that one? That's not obtuse. That's acute. Okay, acute angle, less than 90, but more than 0. Okay, some people say that an acute angle is just less than 90. You've got to be careful with that. Negative 10 degrees is not an acute angle. What the negative means is you went in a different direction. But we'll talk about that. Okay, so when you measure an angle, you basically have two choices. Okay, which way you can measure it. If your rotation from the initial side to the terminal side is counterclockwise, that's considered a positive angle. If your rotation from the initial side to the terminal side is clockwise, that's a negative angle. So I got a little demo that kind of shows you the different ways you can measure an angle. Okay, so what we've got here is a circle. And I can't change the initial side, but I can put the terminal side anywhere that I want. Okay, the box in the lower right, it measures the angle in degrees on the top. The bottom number is a different way to measure an angle, which we don't know about. We will in a little bit. Okay, so straight up, there's your 90-degree angle. Okay, 180, 270, and then 360. When we get beyond 360, okay, to sketch it, you'd have to do something like that. You have to show the spiral indicating you went around one full time, and then you went a little bit beyond. Okay, so there's your positive angles. And if you start here and you go down, you get your negative angles. Okay, so that's negative 90, negative 180, and so on. So there's an equivalence between positive and negative angles in terms of where you end up. So one way to get to this point, which is directly down, is to go negative 90. Anyone remember what the other way was to get to that point? 270. So negative 90 and 270, if you're just concerned about where you land on this circle, are exactly the same thing. Okay? The difference is which direction you went in to get there. Okay? And there's even more ways than that. You can keep going around as many times as you want. Okay? And we're going to learn a way to convert a negative angle into a positive angle by adding something. All right. If you already know that negative 90 and 270 are the same, see if you can figure out what you'd have to add to negative 90 to change it to 270. Right? It has to do with a revolution. Okay, but we'll talk more about that. Okay, so when I ask you to sketch an angle, or if I sketch one, a lot of times I'm going to sketch it in what's called standard position. Okay, for an angle to be drawn in standard position, two things have to happen. Very simple. The vertex is at the origin. So if you draw a coordinate system, put your vertex on the origin. And then put your initial side on the positive x-axis. If you do those two things, you've drawn an angle in standard position. Okay, the program that I just brought up on the screen that I was using, all those angles were in standard position. Vertex at the origin, initial side always stayed on the positive x-axis. Okay. There's another example of an angle in standard position. Okay. Say I do something like that. Is that angle still in the standard position? No, what's wrong with that? The vertex. Vertex isn't at the origin. The initial side is still fine. The vertex isn't at the origin. Okay, what if I did something like that? Is that angle in standard position? No. The vertex is at the origin, but the initial side isn't on the positive x-axis. Any questions on the two criteria you have to have for an angle to be in standard position? Okay. So now I'm going to talk a little bit about how we measure an angle. Okay, so when you guys are telling me it's an acute angle or it's an obtuse angle, that has to do with the measure of it. Okay. How many people have used degrees before, heard of degrees to measure angles? Sure, everybody is used to that. How about radians? How many people have used radians before? Okay. Somebody that's used it, have you used it in your shop or have you did it in another class? Physics? Okay, so you've done it in physics. Is there anybody that hasn't done it in physics before? Okay, so there are quite a few people that still don't maybe know what these are. So we'll talk a little bit about it. So the idea to really kind of start to understand radians is try to make a connection with something you already know. Okay? So one revolution, if you go all the way around a circle, okay, that's 360 degrees. Okay, one full revolution, 360 degrees. Sometimes we use revolutions as a measurement. Anybody think of where you use revolutions? to measure something? In a car. Yeah, if you look at the tachometer, it's usually RPMs, revolutions per minute. If the tachometer said something like degrees per minute, that'd be kind of weird. All right? So we use RPMs. Okay, and what I'm going to put up here is a geometric description of a radian. If you were to try to draw one on paper, what does it look like, size-wise? Okay, so the first thing I want you to notice is this red curved line right here that's on the edge of a circle. Okay, that's called an arc. Bless you. Okay. If the length of that arc that you draw, which is between the two edges of where that angle would intersect the circle. Okay, so that angle just keeps going, but I'm looking at the 2 points where it hits the circle. Here and there. If you measure that arc, like take a piece of string, measure the arc, and then you take that piece of string and you measure the radius. If the measure of that arc and the length of the radius come out exactly the same, then the angle that you drew is 1 radian. If the arc comes out longer than the radius, then your angle is bigger than 1 radian. If you draw it and your arc came out smaller than the radius, then that angle would be less than 1 radian. Okay, but geometrically, that's what a radian looks like. In a little bit, we'll come up with a number. How many degrees is it? So that's a pretty accurate sketch as to what it would look like. It's a little more than 45 degrees, but I'll give you an exact number in a little bit. Okay, any question on this concept? Okay, and this concept is going to come back again tomorrow, and this is important to remember. If I tell you the length of the arc is exactly the same as the radius, that automatically makes this angle how big? 1 radian. That's automatic. Okay? So this fact is going to come back again tomorrow. Okay? In order to figure out a connection between degrees and radians, I got to give you something to start with. I got to give you a fact that I'm not going to prove. You just have to trust me. If you want to measure an angle in radians, okay, the measurement of the angle is equal to the length of the arc on a special kind of circle, on a unit circle. Okay, so I'm going to explain what that is. If you draw a unit circle, any angle that you measure in that circle is going to be the exact same length as its arc. But that only happens on a unit circle. Does anybody know what a unit circle is? It has to do with how big it is. Anybody know what the word unit, what number that's connected with? 1. Okay? A unit circle has a radius of 1. That's all that a unit circle is. It's a circle with a radius of 1. So, if you draw a circle with a radius of 1, you draw an angle in it. The measure of that angle in radians and the measure of the arc are going to be exactly the same. Come out exactly the same. So we're going to use that fact to try to figure out how many degrees are in a radian. 1 radian. Okay, so first of all, I want to think about an arc of a circle that we're already familiar with. And sometimes we don't call it an arc because it takes up pretty much the entire circle. We call it something else. What do you call an arc that takes up an entire circle? And it doesn't overlap. It ends and starts at the same point. What would you call that arc? Yep.
Circumference.
Perfect. We call it the circumference. Okay. And we already know, hopefully we know from geometry, something about circumference. Okay? Because if we know the circumference of an entire circle, okay, then we would automatically know how many radians are in an entire circle, because they're the same. Right? So as long as we can figure out the circumference of a circle, it's automatically the same as how many radians are in that circle, because of this fact. So that's the key. We need to know the formula for the circumference of a circle.
2 pi r.
Yep, 2 pi r. And we also need to know r, but we're working with a special kind of circle called a unit circle. So what's the radius? Yep. How much? Just 1. Okay, you got a radius of 1. Let's fill that in. So if you multiply that out, what's 2 pi times 1?
6.28.
And for now, we don't even have to do the decimal. We'll even leave it with the pi.
2 pi.
So yeah, I should have been a little clearer with that. Yeah, just 2 pi. That's the circumference. So we know the circumference, and it's going to be exactly equal to how many radians there are in a circle, one full circle. So if the circumference is 2 pi, how many radians in a full circle?
2 pi.
2 pi, yes. Okay, now we have a connection between degrees and radians. We know there's 360 degrees in a full circle, 1 revolution. And now we know, because of the fact I gave you, that there's 2 pi radians in a full circle. Okay, you can also see it if you draw it on here. 360 is the same as 2 pi. Well, I moved it a little bit. But. Let's write that down. Okay, and I want to simplify that fact a little bit. Okay, I want to reduce each side if I can. Okay, this fact is kind of like me telling you there's 36 inches and 3 feet. If I told you that, you could use that fact to figure out any conversions. If I said how many feet are in 80 inches, you could use the fact that in 36 inches there's 3 feet to figure that out. But that's kind of a weird conversion. 36 inches is 3 feet. We normally simplify it, if we can, 1 foot, 12 inches. That makes the conversion easier. So I want to reduce this if we can. Is there any number I could divide both sides by to reduce it a little bit? 2. Let's divide each side by 2. So now we have 180 degrees. Half of a circle is pi radians. So that's better, it's reduced, but it's still not equal to 1. Whenever you're doing a conversion, think about any conversion you know. It probably has a 1 in it. In 1 minute, 60 seconds. 1 day, 24 hours. 1 year, 365 days. 1 mile, 5,280 feet. You always have a 1. Well, let's say I want to get a 1 on the, let's start on the left-hand side. What could I divide each side by to change the left-hand side to a 1?
180.
Divide it by 180. Divide it by 180. 180 divided by 180 is 1. Now we know we have this fact. In 1 degree, there's pi divided by 180 radians. Now that we have a 1 here, we could use this equation to figure out anything we want. If I wanted to know how many radians in 2 degrees, all I'd have to do is double what's on the left, double what's on the right, and I could do it out or reduce it. And now it tells me how many radians in 2 degrees, just by doubling each side. What if I wanted to know how many radians in 5 degrees? Multiply by 5. 5 times 1 is 5 degrees equals 5 times, and then we do that up. So the key is that fraction on the right-hand side. Multiplying by pi and dividing by 180. Okay, those are the 2 steps you need to do if you want to convert degrees to radians. Take the number of degrees you want to convert, multiply by pi. That's step 1. Step 2, divide by 180. Okay, those are the 2 steps. Multiply by pi, divide by 180. So all you really need to remember is these steps. Unless they ask for a decimal, we won't use decimals. We'll be leaving pi in the final answer most of the time. Okay, so that's how you change a degree to a radian. Okay, let's go back to the original equation we had. 180 degrees equals pi radians. Now let's say I wanted to get a 1 on the other side. What this is going to allow us to do is convert back the other way. What could I divide each side by to get a 1? Let's get it on the right this time.
3.14? Or well, pi, I guess?
Yeah, pi. Divide by pi. Divide by pi. Now we know 1 radian is 180 divided by pi degrees. So I told you earlier I'd give you a number for that. 1 radian is about 57.3 degrees, roughly. And if you wanted to know how many radians, 6 radians is how many degrees? Multiply this right side by 6, multiply the left side by 6, and then you'd have a formula for 6 degrees. So that fraction is the key right there. 180 degrees is in the top this time, and pi is in the bottom. And it should make sense that it's switched because we're doing the opposite. Now we're going to change radian to a degree. Okay, so the 180 was in the top, that's what we multiply by. Pi was in the bottom. That's what we divide by. Okay, so there are 2 steps. They're very similar, but you got to try to keep track of which one to do when. Okay, the way I'm going to help you to keep track of it is whenever you see the number 180, okay, I want you to think of 180 as the number that we always associate with degrees. Okay, so when I ask you, what number do you think of when you think of degrees? We're going to think of 180. What number do we think of when we think of radians? Pi. So pi is going to be the number you think of with radians, 180 with degrees. Okay, let's try an example. Here's we get 60 degrees. Now I want you to convert it to radians. You only have 2 choices. It's either going to be pi over 180 or 180 over pi. It's going to be one of those 2. But if you think of 60 degrees as a fraction, okay, you've got degrees in the top. We're trying to convert to radians, so we want the units of degrees to disappear. where would the degree symbol have to go in the fraction on the right if it's going to cancel out degrees in the top on the left? Okay. It would have to go in the denominator. So degrees is going to go in the denominator. And what's the number that I said to always connect with degrees?
180.
That's the 180. If degrees is in the bottom, that means the radians is in the top. What's the number that I said to connect with radians? Pi. And now we just reduce that as much as we can. What number goes into 60 and 180? Biggest one you can think of. 60, yeah. 30 works too, but then you can do it again. Actually, maybe a little more careful how I do that. So you cross the 60 out, make it a 1. Cross the 180 out, make it a 3. Degrees in the top, degrees in the bottom, cancels out. The only unit left in that fraction is radians. 1 times pi is pi. 1 times 3 is 3. Radians. Okay, so 60 degrees is pi over 3 radians. Again, no decimals with this. Any question on that? We'll try one where I ask you to round it in a little bit. Let's try 150 degrees. Okay, degrees is in the top. What unit's going to go in the bottom? Degrees. And what's the number we use with degrees? 180. What goes in the top? Radians, pi radians. Okay. Now, I'm going to stop writing RAD. If you look in your book, you're not going to see RAD. Whenever you're talking about an angle and they don't label it, we always assume radians. In trig, the only time you label an angle is if you want something other than radians. Degrees. Okay? So we kind of have to get used to just seeing pi over 3 and pretend that RAD is there. Okay, but our book doesn't write it. Most people don't write it if it's radians. They only write it if it's a degree. So degrees in the bottom, degrees in the top. Cancels out. We could cross the zeros off. And what number goes into 15 and 18? 3. 5, 6. So the answer is 5 pi over 6. Radians is automatically assumed. You don't have to write RAD. Any question on that? Yeah? That's like dividing top and bottom by 10. So it's like I divided 150 by 10 and got 15. Divided 18 by 10, 180 by 10 and got 18. If you wanted, you could just reduce by 30 to start. 30 goes in 5 times. 30 goes into 180 6 times. It'd be the same thing. All right. You guys try those 2 on your own. See if you can convert it. Just leave your answer as a fraction. Okay, if you get stuck, let me know and I'll come help you. This is the first one we've done with a negative. Doesn't change anything. Your final answer just ends up being a negative. Okay, so the first one we'll do is negative 45 degrees. I've got 2 choices. It's either pi over 180 or 180 over pi. Okay, what do I multiply by this time?
Pi over 180.
Yep, it's going to be pi over 180. Degrees cancels out. And what number goes into both 45 and 180?
45.
45, yep. 1 time, and how many times? 4 times. So my answer here is negative 1 pi, or you can just write negative pi, over 4. Okay, the 1 in front of pi doesn't matter. It's kind of like in algebra when the answer is 1x. You can just write x, or you can write 1x. Same thing. Okay, and 90. same thing. Multiply by pi, divide by 180. Degrees cancels. And biggest number that goes into 90 and 180. 90, yeah. Goes in twice. You get pi over 2. Some of the common angles like 45, 90, 30, 60, eventually as you do them a lot, you'll have those memorized. If you asked me how many radians in 47 degrees, off the top of my head, I wouldn't know 47. But I would know 45. And the last one, a little different. Okay, the number looks kind of odd, so what we'll do is we'll round to 2 decimal places. If they want you to round, they will ask you to round. The only difference this time is you just use your calculator and you type it all in. Yep, we'll round it to 2 decimal places. Multiply by pi, divide by 180. I'm going to use the approximately equal because this one's not exact. Okay, this one's just approximate. So 107 times, I usually use the pi button. I'll explain why when we do our next one. Divide by 180. About 1.87. Since that's radians, I do not need a label. Okay, any questions on changing degrees to radians? So we'll finish up with a couple radian to degree. Okay, I put the label in the first time so you can see it, but you got to get used to it not being there. Okay, this time radians is in the top. Where does it have to go to cancel out? Bottom. What's the number that we always connect with radians? Pi. And then degrees is in the top. So this is just exactly the reciprocal. We're just flipping the fraction. If you keep track of your units, that kind of helps you know which one goes where. Okay, what cancels out? Radians cancels out. What else? The pi cancels out. And all you're left with is 180 degrees. Divide by 6, which is 30. Let's try 3 pi over 2. This time, I'm going to show it to you the way the book is going to do it in the homework. It's just going to say convert 3 pi over 2 to degrees. Okay. What are you going to multiply by to change radian to degree?
180 over pi.
180 over pi. Yep. And as long as there was a pi in the original problem, there's usually a lot that cancels out. Those cancel out. 2 divides into 180 90 times. And we're left with 3 times 90 degrees. 270. Okay, and we're going to finish up with one where we have to round. I'm not going to do this one. Three radians. Same steps. Multiply by 180. Divide by pi. Again, how do I know pi goes in the bottom? Because I want to cancel out radians. What's in the bottom cancels out what's in the top. Okay, let's do this one out, and let's do it with the pi button and see what happens. Okay, we get 3 times 180 divided by, use the pi button, comes out to 171.89 if we round up. How do I know my unit? Well, radians canceled out. Degree symbol is the only thing left. Now watch what happens if you use 3.14 for pi. Okay, you got 3 times 180. Divide by 3.14. you get 171.97. 89 and 97 aren't really that close. Okay, that's off quite a bit. So if you see a test and it doesn't specify on the question what to use, always use the pi button. Don't use 3.14. Okay. All right, so for tonight, it's just practicing converting radians to degrees and degrees to radians. Some problems say to round to 2 decimal places. Some say leave your answer as a multiple of pi. That means exact. So it's page 99, 36 to 68, just the evens. Okay, just the evens.